So in this video, we're going to talk about the idea of how to actually make an A in organic chemistry. So I took organic chemistry back in 2016 uh, or 2017, I think. I did really well in my organic chemistry courses, and so I thought I might share the knowledge on you guys before you approach your semester in organic chemistry. Now, organic chemistry is a little bit difficult from some of the subjects that you guys will be would have taken in college. So organic chemistry is mostly for biology majors or some sort of biology related stuff. Chemistry majors obviously may include physics, but not quite sure. But essentially, these are people who want to be marine biologists or a doctor or pharmacist, dentist, etc. You have to take organic chemistry, and it's kind of a different subject area because you've used to taking your biology courses, and organic chemistry essentially it's different, right? So the first and the three tips that I have for you guys, and we talk about them in details. The first one is the idea that, and I'm sure you've heard of it before, but do not memorize. Now we have to be careful with the idea that we say do not memorize because what we're saying is that okay, well obviously there's some things you have to memorize, like for example, your reagents or you know uh, you know you have to know your reagents. You have to know certain things, right? What is the formula for what is the equilibrium constant? How do we calculate? How do we organize its formula? Or just stuff like that. You must memorize. But essentially, when it comes down to the meat of organic chemistry, what we're really talking about are reactions, right? And do you see the reactions, right? So when I say do not memorize, that's what I mean. So you don't want to know a reaction and memorize it totally, right? That's just not how we do well in organic chemistry. So essentially, what I'm saying is that if you're given a reactant, let's say, for example, like this, and you may not know what this means, but let's say that this is a reactant, right? And we do some sort of reaction with it, and we get a product, and this is our product, right? You don't want to memorize this reaction, right? You want to know the general gist of the reaction, but you don't memorize that, okay, well, I have a 2 carbon OH and then I essentially get a 2 carbon bromine, right? That's not how you do it, right? Because the professor could simply change the question in which I have this, and you may see this, right? And so you could see here that if I know the general idea of the reaction, then I should be able to predict the products, or vice versa. I should be able to tell the reactants, right? So you don't want to memorize specific reactions, rather you want to get the gist, right? So in other words, what I'm saying is that, say for example, if I put an alcohol in some sort of base, and I put that in a nucleophile such as bromine, I should be able to predict where the bromine is going to attack, and what should happen, right? Not necessarily the structures involved in the specific reaction. So that's what I mean by do not memorize. Hmm? So I'm pretty sure your professor have told you that before, but again, that's the idea, right? You want to get the general gist of the reaction, so in any scenario, you should be able to predict the products. And obviously, the reactions, I'm using an example because, again, that is the meat of organic chemistry at the undergraduate level. The second thing you want to do is actually, and it actually coincides with the third point, but you want to use pen and paper. Now, if you're a modern student who has like an iPad, or any writing device like that where you could take notes, that's good. But the reason why I say use pen and paper, and actually let me say use pen and paper to study, is important. So, like I said before, organic chemistry at this point in your college career, it's a different subject. And you could see that based on the first point that I've made, you could see that I actually did a lot of drawing. Right? So it's not something that organic chemistry is not like biology, essentially, where I could read a page and kind of really get what's going on. You have to physically write out the reactions. You have to write out the products. You have to draw, right? And so you get better at organic chemistry by doing this. You do not get better by just simply reading a piece of paper, unless you're a PhD student, or a professor who have already mastered organic chemistry. But at the undergraduate level, as a student, you want to use your pen and paper or an iPad, any uh, electronic device to take notes. You want to actually get in the habit of actually drawing these structures, writing your reaction, writing your reagents, right? So use your pen and paper to study. You'll be surprised how much difference it makes, right? Because in some questions you may miss a carbon, simply because you're actually lacking practice, right? So when you're studying, use your pen and paper to study. Write out your structures. Draw your structures several times. Predict the products. Draw the products several times. This is how you study organic chemistry. So it's kind of different in that you can't just read about it as an undergraduate student and be successful about it. You have to actually put pen to paper, right? So that is a huge study tip, right? That's how you become successful in organic chemistry. And my professor once stated that organic chemistry is simply just drawing, right? It's simply just drawing. So essentially, if you don't draw, then you shouldn't be expect you should it should be rational to not expect you to be good at drawing, right? So that is the idea. So you have to put pen and paper when you're studying organic chemistry. The last point uh, that I want to engage in, and it kind of coincides with the second point, is the idea of practice. So remember, I said that my professor pretty much told me that organic chemistry is pretty much drawing. And so essentially, if you think about it as drawing, how do you get better at drawing? You actually keep on drawing and drawing and drawing and physically drawing. So taking pen and putting that to paper, or you can actually use pencils, right? So you want to practice. You want to do a lot of practice questions, a lot of practice questions. So like I said before, if an example come up where you may use this, and let's say you get a product that looks like this, right? Okay, you may want to switch up the problem where I might do an open chain, and let's see if I get something like that, right? The same concept, but different structures, right? So practice, practice, practice. It is not like your biology courses, or any other course that you may have taken thus far, where you could just simply read about it and you're good, right? It takes physical practice. So you writing out the structures, you writing out your reagents, you predicting the products, going backwards, right? So having a product and predicting the reactants, etc. Right? So practice, practice, practice physically. So you want to put pen to paper. I think if you do this in organic chemistry, you should easily you should easily get an A in organic chemistry if you do these three things.